Hi everyone. Today I'm going to present about Facebook's Profit, which is one of the forecasting algorithm. And I based my presentation on the research paper itself called Profit Forecasting at Scale. So to shortly introduce what Profit is, it was introduced by Facebook by their employees, Taylor and Leatham in 2018. And it's used for forecasting univariate time series by decomposing the time series into smaller pieces. And the authors actually emphasize that it's made easy to use so that everyone will be able to use it, especially for domain experts. And in the introduction part of the research paper, the authors mentioned that the business forecasting method should be suitable for a large number of people making forecasts and also for a large variety of forecasting problems. So to summarize, the authors mentioned that a large number of forecasts should be created so that an automated means of evaluating and comparing the forecast should be possible. So here you're looking at a number of events on Facebook in 2013 to 2016. And the dots you see here are points for each day, and they're color-coded by day of week. And if you see the overall graph, you can see that it has a yearly cycle. Similar waves appear in each year. And also, if you look at the colors, you can see that it also has a weekly cycle. The distribution of similar colors remain in the similar positions. And based on this raw data, the authors of this paper have tested with different types of forecasting methods, especially the forecasting package in R. So starting from the top, we have AutoArima, ETS, SNAIVE, and TBETS. And as you can see, AutoArima is very prone to trend changes. If the previous dots seem to decline, the AutoArima applies that in their forecast, and it shows a drastic decrease in the predictions. So it is useful for trends that are very sensitive. However, the overall result is not very accurate. And for ETS and SNAIVE, they kind of show weekly seasonal cycles as the color codes remain in the similar positions. However, it does not really represent yearly seasonal cycle. And for TBETs, it seems to show the most accurate prediction compared to other models. However, the result is not that ideal. So to create a better model, Facebook Profit created a decomposable time series model representing three components: trend, seasonality, and holidays. And this is later on added together using a generalized additive model, GAM. And it's more like a regression model rather than a traditional time series model like ARIMA. So for a beginner like me in time series, it was easier to approach since Profit is more like a curve fitting exercise rather than having to do a pre-processing for the data, especially in the temporal dependent structure. So each of the components, they represent trend, seasonality, and holidays. And I was watching this YouTube Profit conference video, and one of the authors, Sean Taylor, actually simplified these variables like this. So you don't have to really think of it in a complicated way. We can just think of the trend variable as L1 regularized regression and function S as Fourier series and holiday variables as dummy variables. So I'll explain this step by step. So first of all, function G is a trend model and provides two types of models. First one is a saturating graph model based on logarithmic trend. And second one is a linear model using regression broken into different types of data using knots. So knots here, the user can select, or it can be automatically selected, but you can just think of knots as different time steps. And the regressor actually think of these different time steps as different prediction time series. So it becomes important in later slides, I'll mention later. And so for the first type of model, the saturating graph model, it follows the typical logarithmic graph model. However, some of the variables, such as the capital C, it represents a carrying capacity. However, when it comes to Facebook data, the number of carrying capacity keeps on increasing because the number of people having access to internet increases. So this was replaced with a time varying capacity, function C of t. And the growth rate also had to be modified because it bases changes depending on different knots or change points. So this is how the equation was modified. And the offset parameter also changed depending on the growth rate. And also for the piecewise linear model, it's quite similar to the logarithmic model. However, it bases its equation as a linear model. So ax plus b takes a format here, except for the change points as rate adjustments as a delta variable. And if the change points or delta variable is not selected by the user, it's automatically selected by taking a sparse prior as a Laplace function ranging from 0 to tau. So the tau variable here controls the flexibility of the model. And that will be for the trend function. And for seasonality function, it basically takes a form of Fourier transform. So the user can adjust two types of variables. Variable P represents a regular period. So you can input 365 for yearly data and 7 for weekly data. And also for variable N, it's used to construct a matrix of seasonality vectors. So according to the paper, when N was equal to 10 or 3, it seemed to work best for yearly and weekly seasonality. However, increasing N creates fitting seasonal patterns that changes more quickly. So it may be prone to overfitting. So user has to take account of the size of N when adjusting the parameters. And lastly, for the holidays variable, in Facebook, they took account of Thanksgiving, Super Bowl, or Christmas as holidays. And it's basically a one-hot encoding matrix or a vector. And this function z, which includes the vector, is multiplied with a kappa variable, which is part of a normal distribution. So all of these variables were combined using stance L BFGS. And this is actually not a topic that I'm familiar with, so I won't go deep into this, but basically you can see different variables, K, M, epsilon, delta. Delta is the change point, and delta is a seasonal variable. And all of these priors were combined whether the regression took a logistic or linear format. So, yep, you can also choose whether to use MAP or full posterior. And the results of profit forecast was like this. So this is the same data that I mentioned on the introduction part. The prediction using ARIMA and ETS was the same procedure was used here for the profit forecast. And the top variables only predict certain parts of the forecast. However, the bottom graph used all historic data, including the interpolation. So as you can see, it's quite accurate. But my assumption is that the authors may have used a little bit more effort in hyperparameter tuning in profit compared to other algorithms. But anyways, Profit also provides a different types of visualization for each variable. Like I've mentioned, the trend, weekly, yearly variable, you can see how the trend has changed and what day of the week has the most correlation with the time. And also the same applies for the day of the year. And yep, from the user's point of view, the parameters and profit can be adjusted, such as the seasonality parameters and how often the change points are expected, the functional form of growth, whether it's a linear format or logistic format. And the holidays can be also customized, the seasonalities, and just like I've previously mentioned, MAP or full posterior can be chosen by the user. And the way Profit is installed is quite simple. You can just use the pip package. You have to install Python first and then Facebook Profit. And then after importing required libraries, you just have to load the model, setting some custom parameters such as confidence intervals and whether you want to keep the daily seasonality. And you can just train the model by calling the fit function and predict the forecast by using make future data frame and predict function. And you can manually set how many days you want to predict by putting number in the periods area. And other than that, Profit always takes the variables such as you have to name the date-time column as DS and prediction variable as Y. And after doing this, you can just call the plot function for simple visualization. So here you're looking at the black dots as actual values, the blue lines as predictions, and the shaded area represents the different bounding boxes or confidence intervals. And you can also call plot components function to see the decomposed functions. So to conclude this presentation, I just want to mention why Profit is forecasting at scale, since I didn't see any type of metric or scale included in the paper. However, the authors mentioned since Profit is a simple adjustable model and has a scalable performance and monitoring in combination, it will allow a large number of analysts to forecast a large number and a variety of time series. In that notion, the authors have concluded that Profit is forecasting at scale. So, yep, that's it for my presentation. Thank you for listening.